Okay, welcome back again. This is the second part of trigonometry 1. We talked in the first part about the arc length and about the sector area, how to calculate these, and hopefully you solve the problem I ask you to solve it. In this part, we are going to talk about basic trigonometric functions. What I mean by functions is these: sine, cos, tan. And later we are going to flip these upside down. So if we flip sine, we'll get 1 over sine. This one we call it cosecant. We'll see it later. Some students confuse between sine inverse and 1 over sine. These are not the same. These are two different things. Yeah, it's early to talk about it, but it's something to ask you to pay attention to it. Now we have right triangle, and then we are focusing on this acute angle. This side is the opposite to the angle, and this side is the adjacent, and the big guy is the hypotenuse. And we define sine, opposite over hypotenuse, cos, adjacent over hypotenuse, and tangent is opposite over adjacent. Tan is sine over cos. So if you put this on top of that and you reduce hypotenuse with hypotenuse, you are going to get this one. Okay? Question: why they defined like that? It's the definition. We don't have the right to say why. Since it's defined, that's it. That's the definition. Let's go next. The 360, or a full revolution, split it to 4 quadrants. Quadrant 1, 2, 3, and 4. So 1 from 0 to 90, and then 90, 180, and so on. When we move counterclockwise, theta is positive. When we move clockwise, theta is negative. So when, for example, if we have an angle in here, this is roughly 45 degree. But if we have an angle in here, this is negative 45 degree. That's the only difference you need to know. How about if we have an angle more than 360? It's the same. Like if theta angle equal, let's say 360 degree plus 10 degrees. This is same as 10. Because the full revolution is doing nothing. It's going to bring our vector to the initial position. We could see it in here. So what they want, draw a diagram for 400. This is positive. So if it's positive, then I need to move clockwise. That's the clockwise. So this is 360. I'm done. So my 400, it's split it to 2 pieces, 360 plus 40. Then the only thing I need to go is 40 degrees. So this one is same as, this is 40 degree, but it's equivalent to 400 degree. Okay? In negative, also the same. We have negative 480. Negative 480 could be written as negative 360. So we come in here and we move clockwise. That's negative 360. We done. How much left? 120, but in negative direction. So we'll go negative 90, negative 30, and this is the final place. It's very basic. What they want in here, consider point P on the circle of radius R. Okay. Back to the definition of sine. Sine is the opposite. That's the opposite. The opposite is the highest. Here. The height of the point, which means y. That's y. Over the hypotenuse. That's the hypotenuse R. So that's the definition. Come from nothing new. It's opposite over hypotenuse. Cos is adjacent. That's the adjacent, which is the x component of the Tan is going to come by itself from sine over cos, so we'll find it is y over x. Okay, let's see if there is some problems we could solve. Yeah, write down the value of sine 90 and cos 180. Sine 90, here, we are in here. Let me make another angle. This is less than 90. So let's say this is r, and we know the sine is the opposite, which means this over that, y over, so sine equal y over r. Look what will happen to y if I increase the angle. Y is going to be bigger. When it's 90, y equal to r itself. So sine 90 will be r over r, which is 1. Cos 180, here, that's 180. Cos is adjacent over hypotenuse. Look to the adjacent, how much is it? It's 1, but in the opposite direction, so it's negative 1. R always positive, there is no negative radius, 1, so the answer is -1. Okay, these are some angles you need to know, like very basic. I know like most of you from the previous years, they know these values. Sine of, you need to add 0 and 90 also, 0 degree 90. These equal to these values. I'm going to prove them in next slide. Take a look. If we have equilateral triangle, a triangle where all the sides are the same length, we call it equilateral triangle. Let's pick number 2 for this. You could pick any number, but 2 is going to make it so easy, because we need to split this to 2 pieces. But if you put any number, it will be fine, no problem with it. Anyway, if we split this angle, this is very basic geometry. This one is going to go perpendicularly in here, so I get a right triangle. And this angle split it from where we get 60. Since the length of the side are the same, then the angles has to be the same. So 180 is the total of the triangle. Divide by 3, we get this 60. This 60 split it to 2 pieces, so it's 30. Now you could apply sine 30, or let me start with 60. Sine 60 here is the opposite. Opposite is root 3. This one, how we get this root 3? We get it from Pythagorean theorem. This is question mark, this is 2, this is 1. So 2 square equal 1 square plus the question mark square. And then when you apply, you will find that this is just root 3. Then you will see this is the cos 60 is opposite over, sorry, sine 60 is opposite over hypotenuse, root 3 over 2. And you just apply the formula. You get all what you need. Let's go to the other triangle. This kind of a triangle, we call it isosceles triangle. 2 sides are the same. We don't care about the third one. How much is it? So we pick like 1, the length. You could pick any number. You will get the same answer. But 1 make it easy. How we get this root 2? Again, Pythagorean. A square equal b square plus c square. So 1 square, 1 square. This is 1 plus 1. And then a equal root of 2. If these are the same, 1 and 1, then these angle must be the same. This angle is 90. What's left for this is 45, 45. And then you could do the sine cos of 45. You just take a look to the opposite and hypotenuse. Okay? find the exact value of 135. Since 135 is not an acute angle, we need to make it acute angle. Take a look, this is 135. 45 is an acute angle. We know what sine 45. Sine 45, we just done with it, is 1 over root 2. Sine 45 is 1 over root 2, or root 2 over 2, same. The question is sine 45 equal to sine 135? That's the question. The answer is yes. Why? Because here, see, these are the 4 quadrants. Quadrant 1, 2, 3, 4. In quadrant 1, all the functions are positive. What I mean by the function, sine, cos, tangent. In here, all of them positive, positive, positive. In the second one, just the sine is positive. The other 2 are negative. Canadian says all the soup turn cold. So first quadrant all, second one is the sine, third one tangent. That's the only thing you need to know. That's 135 in second quadrant. So if they ask about the sine, we are good to calculate, to replace it by sine 45. Okay. Some application. There is a shade. Sun make a shade. This tree make a shade with some length, and the angle of elevation is given. They need the height of this tree. Height is opposite, and this one is adjacent, so we use tan. Tan the angle equal the opposite over adjacent, and the opposite is the height itself. The adjacent is given. Of course, an angle like that, you need a calculator to find the value. And that's the answer for this. Let's go next. In this one, there is a flag on top of the building. And if you omit the flag, then this problem is the same as the previous, the tree one. So this is given. The angle is given, this one. And then we could get the height. Okay? Well, I'm not going to solve it, but this is your turn. So you are going to do it. I'm going to post it as problem, and I'll give you multiple choice. Try to do it, and then click next for the third part of the lecture. Okay? I think this is a good place to stop, and I will see you in the third part.